I'm really excited to announce our guest speaker today, Nikhil Garg. Nikhil is a PhD candidate in electrical engineering at Stanford, and he is a part of both the Stanford Crowdsourced Democracy team and the Society and Algorithms Lab. He has an NSF Graduate Research Fellowship, and he has spent time at Uber, NASA, Microsoft, the Texas Senate, and IEEE's policy arm, which I think is a really amazing diversity of places. His work has been covered in the New York Times, Science Magazine, Smithsonian Magazine, Stanford Engineering Magazine, Stanford News, and other places. So with that, we'll welcome Nikhil, and he invites questions, and I'm going to try to use the catch box to catch these for the questions. Yeah, thank you, Nikhil.
Thanks. Thanks for having me. And just to emphasize, I'm going to make this more of like a classroom style talk as opposed to like a research talk. So feel free to interrupt and so on. And I think that will motivate some of how I structured this and what we'll talk about at the end, hopefully. So this is some recent work on how to use word embeddings to quantify gender and ethnic stereotypes. And more generally, I think unsupervised machine learning outputs sort of have great promise as a lens on our society. And so that's, I think, the framework for this talk. So just a quick primer. I know y'all are now experts in data science and natural language processing, so I probably don't need to do this. But I'll just give a quick primer on word embeddings, which they're numeric representations of words in what I deem is a low dimensional space. Low because it's, I think, somewhat surprising or inaccurate to say that 300 dimensions can capture all the complexities of language. And so, as I said, there are models of the world, incomplete models of the world, and such that similar words will have similar numeric representations. And a lot of prior work has shown that word embeddings can encode a whole host of things about language, semantics, syntax, relationships between words, and so on. And they're primarily trained through unsupervised methods using extremely large data sets, such as all of Wikipedia, all of Google News, a corpus of every American book, or so on. And they're, of course, a building block of modern natural language processing. So prior work before ours, there's, of course, a bunch, but two that I would like to highlight really, I think, emphasize that word embeddings can encode biases or stereotypes in language or in our society. So the first one, through a bunch of analogy-type tasks, focus on gender bias, and then talked about how to debias word embeddings. And then sort of the second paper, I think it was in Science, showed that word embeddings basically replicate every human bias on the implicit association test. So gender, ethnic, what have you. Basically, all of those are replicated. And what I would emphasize here is that embeddings are thus a model or represent language as it is used, not just language as we may wish it's used, or sort of some formal notion of our language. And the idea of our work was that this is, of course, harmful in many contexts, and we'll get to that at the end, but it's also useful. In particular, documenting and auditing historical beliefs is something that's important to do, just as studying or knowing about how beliefs have changed over time, but it's also very hard to do. There's a very limited set of consistent historical surveys on what did people think about certain topics over time, but they're a little sparse. And so the idea is to augment some of those historical works with word embeddings. And here, of course, showing, sort of taking advantage of the fact that the representational power of embeddings is useful. Okay, so sort of a very high-level outline of the talk is that first I'll just summarize the methodology at a very high level, and then I'll walk through a bunch of examples, one confirming that we can actually do this, because there's, of course, a bunch of potential pitfalls. I'll present some some exploratory findings, but then I would actually like to spend a substantial amount of time on limitations, both in this work and this type of work in general. And especially there, I'm happy to have a discussion. Okay, so the high-level framework in the paper is actually pretty simple. We start with some embeddings, so just train embeddings on some data set. And the assumption here is that the data set is a proxy for some society of interest. And then we compile two lists of words. First is what we call group words that will quote unquote represent populations of interest. The ones that we use in this work are, for gender, we just use a bunch of pronouns and like relationships for gender. And then for ethnic groups, we use common last names derived from the US Census. And then also compile a list of what we call neutral words that represent potential characteristics that people can have, so either adjectives or occupations or what have you, whatever is of interest. Then just from the embeddings of these words, just calculate the distance between groups and neutral words, and then compare distances across groups. So if a certain characteristic is closer to one group than the other, then we would say that the embeddings are biased toward that group over the other group. And then in some cases, we can compare these relative distances to outside data just to confirm that these are capturing something real. There's a bunch of assumptions in everything I just said, from the embeddings representing societies to group words and so on. I'm going to save that till the end, talking about how these assumptions are present in this work and also a lot of natural language processing in similar domains. Okay, so the first example, which also appeared in other work, so this isn't novel or anything, is look at embeddings that are trained on Google News. These are available online, and just have two sets of group words. One set of group words representing men and another for women, and then the neutral words are a set of occupations that you can come up with from the census, for example. The additional data that we use to compare are a percentage of, is a breakdown of what percentage of that occupation in the United States is each gender, and this is through census data. And then we sort of augment that with a Mechanical Turk survey that was actually provided to us by the authors of the first paper, the Buluk-Bassi paper that I put up. And here, what the authors there did was run a Mechanical Turk survey on sort of what workers characterize as stereotypes of each occupation. And so this is trying to see, yeah, I'll get into this. So what this plot shows is, so on the y-axis is the relative distances of each occupation to either the group, to the set of words representing men or the set of words representing women in the embeddings. And then the x-axis is the occupation difference by percentage in the US Census, I think in 2010. So it's somewhat noisy, but there's a clear pattern that embeddings are, as a whole, capturing the trend in how skewed the occupations are toward one gender or the other. And we highlighted just a few sort of outlier occupations. And then we can augment this with the Mechanical Turk survey. So what it turns out is both human stereotypes and the stereotypes in the embeddings don't actually reflect reality. It's sort of here I'm defining reality as the occupation percentages. And human stereotypes tend to be sort of in addition to that sometimes. So, and it turns out that the embeddings capture that difference. So here, if you would see the residuals on the plots are, one, noise, but also variance that's unexplained by the occupation percentage. So biases in the embeddings that are somewhat additional to the skewness in the occupations. And it turns out that the residuals here correlate with the Mechanical Turk, with the additional residuals on the Mechanical Turk survey as well. So sort of showing that this embeddings technique can capture both, again, I want to put underlying reality in very big air quotes, represented by the occupational data, but then also additional potential biases or stereotypes by human workers on Mechanical Turk.
I have a question.
Yeah.
So with the, I guess like the distance from the line, for instance, is this showing that kind of both the embeddings and people expect way more women to be nurses than fits the occupational data of more women are nurses, but not to the extent that the embeddings reflect?
Exactly, yes.
Okay, so it's kind of like the bias has been amplified, or the stereotype has been amplified.
And so I don't want to make that specific claim, in that at least we didn't find any like systematic pattern of like certain types of occupations is amplified or so on.
Yeah.
It's just that the residual in either direction is explained. It's somewhat explained by the embeddings.
Okay. And then so with secretary, the embedding, I guess, kind of captured secretary as being more masculine than the occupational data?
Yes, and I think the secretary one in particular might have actually been just because the disambiguation of secretary into maybe cabinet secretary in the United States and other types of secretaries. So yeah, so not all of these residuals would be captured by human stereotypes. Some of these are, of course, due to other technical limitations.
Oh, thank you.
Any other questions? Or? Okay, so once we have this general framework, we want to sort of verify it further. And in particular, what the interest of our work was, can we do this consistently over time? So not just on one embedding in a snapshot setting, but can we consistently look at biases and embeddings and say 1940 versus 1960, and then say something meaningful about the differences in those biases. So, in particularly, we want to verify that embeddings are calibrated to changes and whatever else biases of historical beliefs. And so one thing that we do, for example, is continuing this trend of using census data. We using the corpus of historical American English, which is essentially a not gender balanced, it's a sort of genre balanced collection of books of American English written throughout the 20th century. So using this corpus, we can train embeddings for every decade, and then we can capture as we did in the previous slide, we can do the average bias in the consistent set of occupations over time, and then we can compare that to the mean of women in those occupations throughout the 20th century as well. And sort of there's of course some noise, but what I want to emphasize here is that there's some hope for calibration, is that there's a consistent mapping, roughly consistent mapping from, let's see what the bias was in 1920 to what that maps to in terms of occupation percentage, and then the same thing in 1980. We do this for sort of a few other settings where we have historical data. So there are a few sets of historical surveys that were repeated over time. So there's the famous Princeton trilogy, which a researcher in 1933, 51, and one other date that I'm forgetting, asked a set of Princeton undergraduates their stereotypes of a whole bunch of different ethnicities. And yeah, those are somewhat disturbing and fascinating to go through. But yeah, so this researcher asked consistently very similar questions on stereotypes for ethnicities, and we essentially just replicate that the differences in the stereotypes between 1933 and 51 are also reflected in the differences in the embeddings from those decades. And of course, we using the Mechanical Turk survey in the previous slide. Okay, so now I'm just going to do a fairly quick run through a bunch of various stereotypes that we quantified in the paper. These are, I want to emphasize, exploratory in the sense that we can't validate each of these against some fixed like outside measurement, because a lot of those outside measurements, those don't exist. Also want to give the warning that I'm going to present some stereotypes in the slides, so they're going to be gender and ethnic, so if you're uncomfortable with that, yeah. Okay. So this first slide shows Asian stereotypes in the corpus of historical American English in 1910, 1950, and 1990. And so how we generated these is sort of the same high-level methodology of collecting a group of, so a set of group words, which are just common Asian last names, and then a very large list of adjectives found online. And then we found which adjectives are most similar toward Asians and dissimilar toward white last names in the embeddings in 1910, 50, and 90. And sort of there's a progression, I think, that you can see where 1910 is very much an outsider type of stereotype. This was before a lot of the initial waves of Asian immigration in the United States, or sort of before what people considered integration. And then in 1990, these outsider stereotypes, at least, have been replaced with other stereotypes. This one is just the average association between Islam and terrorism in the New York Times between 1988 and 2005. So same high-level methodology here is we collected a bunch of words that we considered to represent Islam, and also a bunch of words that we considered to represent terrorism, and just looked at the differences between sort of how close those words were to words representing Islam versus words representing Christianity in the New York Times. And so there's some peaks after, for example, the World Trade Center bombings in 1993, as well as, of course, 9/11. And it would be, I think, interesting to extend this past 2005 with a larger New York Times data set. This one's, I think, a little tougher to explain. What this is a heat map across decades. So we have in both the X and Y axes, we have from 1910 to 1990, and these are just the correlations and how similar language is in those 2 decades with respect to adjectives and gender differences. So sort of the more blue the cell is, the more similarly biased or skewed adjectives are as a whole in terms of gender. And this is one that so one of the collaborators on the paper is actually a historian of gender and science. And this is one I think that she particularly found interesting, is sort of there's a somewhat marked shift in the 60s and 70s when the women's movement in the United States really brought a lot of issues on how are women talked about in media or books or what have you, that at least we found somewhat of a quantification for that actually had an effect in positive effect, I would say, in the language. Okay, so that was just a very quick run through for the types of analyses that we did for quantifying various changes over time. Now, for the rest of the talk, I'm going to sort of, I promise that there's a bunch of limitations in this sort of work, and I'll just discuss a few of them. So here, I brought back our high-level framework, and now I'm just emphasizing a few words that are, I think, indicative of the assumptions that we made. So we trained embeddings on some data set that we claimed represents a society of interest. So for example, we trained books from 1910, and we're claiming that these are indicative of American societal thoughts or what have you in 1910. We compiled a list of words that represent categories and then claimed that these words are good enough to represent those categories. And then we calculated the distance between groups of words, and then we claimed, or at least assumed, that the distance is meaningful. Each of these steps is baked with some assumptions that I'll go through now, and I think at least a few of these assumptions are pretty common, or I think problematic assumptions are pretty common in a lot of this type of work, and it's something to be aware of as maybe you're pursuing similar types. Okay, so for example, we used an existing corpus of text from American English books, and we claim that they represent historical American beliefs. But there's a bunch of people that this doesn't include, right? This doesn't include Americans who didn't publish books at that time. This doesn't include Americans who published books in other languages. Or we compiled the distance into a single metric from 1910, but what about minority ideological opinions at that time? These are all washed away in some mean of distance. And then there's a whole bunch of, I think, power or whatever issues in who created the data set and what decided what text would go into that corpus. None of these decisions are very, or at least someone who just read the paper are obvious. I, for example, don't know the decisions that went into making the corpus. And then the second, I think, more technical issue that there is more headway on is that embeddings themselves are black box algorithms. So there's a bunch of different ways to train embeddings, some that are, ever getting improved from, GloVe to Word to Vec to BERT or what have you. And then we just calculated the Euclidean distance between two vectors, and we claim that that represents something about these embeddings. This one I say that there's more progress on because at least in our paper, we in the appendix, we do a bunch of robustness checks that the distance function really doesn't matter. The algorithm used for the embeddings doesn't matter, and so on. And there's follow-on work on, I think, using much nicer fine-grained embeddings that instead of just training different embeddings per decade, you can actually have embeddings tuned and changed over time in a very smooth way. Like not just year by year, but with additional data. And so I think this second issue is more of a solvable problem technically, but I think the first issue is something that there's never going to be a technical, or not never, that there isn't a technical solution for at the moment. Similarly, we claim that words represent a category, and in particular, for example, we use lists of words to represent binary gender, and then we use common last names to represent ethnicities. But similar set of questions. This basically forgets about non-binary or multi-ethnic people, or people whose last names may not reflect their self-defined ethnicity. It makes use of historical census classifications of ethnicity as well as occupation. And one very concrete limitation of the methodology is that we couldn't distinguish between white and black Americans because it turns out, at least in the US, the overlap in the distribution of last names are pretty similar. There's, of course, a few exceptions, but as a whole, the last name distribution is similar between white and black Americans. Okay. So, yeah, okay. So stepping back to similar challenges that are present in NLP or data science work in general is that language is messy, and language as a whole can probably take care of a lot of issues that I talked about. But in computation, when we start using language as data, we, by definition, have to simplify, and that involves categorizing and summarizing this messy language. And this categorization and summarization process is not objective, and you can never hope to make it objective. Or at least in my view. That there's all sorts of issues on who's creating the categories, on how you're categorizing. So for convenience, we used binary gender because it was hard in the paper to, for example, construct groups of words that historically would be able to represent any other. And this, of course, ignores those who fall between categories, or maybe the categories aren't discrete enough or granular enough or aren't well defined. And And so that's about categorization. And then on summarization is, again, in the paper, for plots or to describe things, you need a single number, maybe a single number representing an entire decade of data. And this is a summary of some kind, and in summaries and means, sort of the minority opinions tend to be washed away, or sort of not accounted for in the mean properly. And then a more general question is, a lot of these word embedding models are, trained on, of course, large corpora of data, like all of Wikipedia, and then they're summarized and used to train models that are then applied to everyone, including potentially minority opinions that were washed away in the creation of the embeddings. And that, I think, a whole host of literature in the past few years has described how this is problematic in a bunch of applications. And so, stepping back even further, embeddings and unsupervised learning models, or just machine learning models in particular, often construct incomplete models of the sometimes problematic world. And this is not always a bad thing, in the sense that our work couldn't have existed if embeddings didn't capture this sort of structure. But in other applications, these stereotypes embeddings may be undesirable, and it's a question for when is it undesirable, who decides if it is, and then how do you debias, and should you debias? And these are all things that are something that you should think carefully about, and something that I want to emphasize is you thinking carefully about it is probably not enough, in that I'm not an expert on these issues, you probably aren't either, and you should probably collaborate with and talk to people who are. For example, this work benefited pretty greatly from sort of talking to and collaborating with Londa, who is a historian on these issues. Yes, that's sort of all the prepared talks that I had. Definitely open to questions or discussion on these issues. And links to the paper, probably easier to Google around and then try to follow the link.
Any other questions? Hi, thank you for the talk. Am I using this correctly? Okay, thanks. I'm just wondering, did you mention the example you gave for the Muslim and terrorism, you said you select a list of words that are associated with those two, and then you compare the correlation of them along with time. Is that so? My first question would be, how did you pick those words that are associated with the term? And secondly, are they updated in different time periods?
Great questions.
Thank you.
Yeah, so you described the methodology correctly, I think, is pick groups of words that represent Islam and terrorism and Christianity, and then look at the relative distances between the group words and the words describing terrorism over time. So I think the two questions were, and correct me if I'm wrong, is one is who picked the words, and how are the words picked, and were they the same over time? And I think this is exactly the type of issues that I was talking about earlier, is that these are important questions that are often glossed over on, like, how sensitive or sort of who defines these categories. And for the most part throughout the paper, we tried to just find as most general and large lists that other people had compiled online as possible. For I believe the religious and terrorism words, we started with lists found online, and then sort of like removed overlaps in some sort that would sort of skew the results. So I think like various lists online sort of, for example, use madrasa as a word, as a word describing terrorism, but that also has a more benign meaning, I think. And so like little issues like that we had to hand remove. And yeah, so it's definitely not a perfect process. And then the second question is sort of, are the words consistent or the same over time? And yes, essentially, there's sort of the words as a whole. I think sort of how we did it was, so we started with these original large lists, and then looked from that, filtered it down to just the words that appear enough over time, so that you're not going to have really high variance estimates in any particular decade, and then use that smaller list that appears over time.
I have one follow-up question to that and then a different one. So on that process, and I was curious about the same thing, the problem with keeping a consistent list is that the good thing is it's consistent, and then the bad thing is that it's consistent in that word use and language selection varies massively over time. So keeping that list can be just a measurement of when a word gets popular on that list and when it isn't. And so have you guys thought about controlling for that? That just came up. But more importantly, I think now that it seems very clear that the sort of embeddings and algorithms are getting there in terms of really extracting really good context, is anyone thinking about conducting, has it already been done, this main issue, which is like if you use 100 years of white authors, it's going to reflect that, but actually go in there and actually try to fix that problem in a systematic way, with like replacement of these books or a consensus corpus, but then not just get a consensus from these external partners, but then test whether the consensus does improve things, change things, or if there is something more general despite the lack of representation in the language.
Okay. Great question. So I'll tackle the second one because that's the one I remember currently. So I don't want to pick on the Corpus of Historical American English. It's a great data size compiled by, I think, social science experts, and for, I think, going through that process in the first place. So they genre balance, and they did a lot of things to make sure that the books were comparable over time. So in some sense, that is the output of a process like the one you described. But sort of, no, I guess I haven't seen a lot of work on sort of compiling the right data sets to train embeddings like this. I think I have heard of, I forget the citation, but I have heard of some work on how you can, during the training process, for example, you can like flip genders in sentences and like in the training data and so on. So as opposed to actually compile representative sources, which may be hard, do training process fixes. So the first question, I think, was on are consistent word lists themselves a problem? And can we correct for that? So that certainly is. And so, for example, one thing that we thought about doing in this work is, so our methods for distinguishing between groups of people was using last names, which has the benefit of being somewhat consistent in the census historically, and sort of last names, unlike first names, are decently consistent in describing ethnic groups. And so one thing but it of course fails to distinguish between white and black Americans. Other work has used first names for that purpose, and we thought about doing that, but then we would have to do exactly what you said, is correct for first name frequencies differ by generation quite a bit. I imagine it can be done. I haven't seen work that corrects it for exactly in contexts like this, but definitely interesting avenue to explore.
I just wanted to kind of make a shout out to the paper NLP Statements by Emily Bender and Batya Friedman, which is, I think, a relatively recent paper. But I love the list of questions you had about kind of who creates the categories and who was included versus excluded. And just the idea of the NLP statements is to record these things about any data set. And so that, doesn't resolve the fact that people are probably still being excluded or included, but it would at least provide kind of a record of, these are the people that created this. And they give a few examples in the paper of kind of if you're using like Amazon Mechanical Turk workers, even to say kind of like what were their ages, what countries were they from, what variants of like even within English, are you using kind of British English versus Australian English, these variations. And so just to even have a way of kind of like documenting how these data sets were constructed. I thought that was an interesting paper recently. I was just going to ask about the choice of using Euclidean distance versus cosine distance, because I know sometimes in higher dimensional spaces people use cosine distance.
Yes, I think part of the intention so yes, definitely that was a choice. And I think part of why we did it is Euclidean distance is just easier to explain and visualize. And so I think we show in the appendix that it really doesn't matter. That sort of like the noise is different maybe, but really for like a whole host of these things, it's like within the noise of everything else. And so regardless of distance metrics, some like essentially identical patterns are going to emerge. But yeah, the sort of another, I think, danger of work like this is, I think, well, first, not abusing the researcher degrees of freedom that you have, but then two, documenting that you didn't do that, and providing as much robustness checks as you can, as is feasible or appropriate in the appendix.
Other questions?
I know this is something that I think Rachel's planning to cover in a future lesson, but there was a paper last year, I think, called FRAGE, F-A-R-G-E, which showed that the kind of principal component of word vectors from word-to-vector glove is actually word frequency rather than word meaning. I guess when David asked his question, it made me think, is that going to be particularly an issue here when you look for similarity between two words, that it's going to particularly show change in frequency because that's such a major component? Or did you actually kind of try to remove the frequency eigenvector out of the representations?
So I'll answer this last question first. So no, we didn't do any pre-processing, like removing principal components. But concerns like this of there's just shift in the embeddings for all sorts of reasons. Like there's no reason to believe that embeddings trained on one data set and then trained on another data set, even if the data sets were meant to be comparable, there's no reason to believe that the resulting embeddings are comparable for all sorts of reasons like this. So I think there were, that challenge in particular motivated two of the things that we did. The first one, which I'm not a huge fan of in general, but I think for challenges like this we need to, is all the results in the paper are sort of comparisons. So they're not just what's the average distance between this group and the set of neutral words, but it's what's the average distance between this group and these neutral words minus the average distance between another group and the same set of words. The hope is that this sort of normalizes away some of these issues, but if that's not satisfactory, that's, I think, the purpose of the validation in the paper. So we're definitely concerned of things like this, but the sort of the various validations that we did with available historical data shows that while that may be a problem, it's not, at least first order as far as we can detect, that the method as a whole is decently appropriate for comparing over time or across data sets.
Thank you.
Question over here.
Hey, so I guess my question for you is, goal-wise or mission-wise, kind of what was the goal of doing this kind of research? Is it like to be kind of prescriptive, to maybe implement new rules and new understandings of language, or is it just to kind of be like, okay, if you're going to do NLP work, here are some things you can consider? Because for me, you know, if you're doing research on gender and ethnic stereotypes, at some point you have to define genders and you have to define ethnicities. I think that gets really hairy when you start thinking about ethnic minorities in a lot of different countries. Even if you try to even define what black means in America too, I mean, you get into some hairy things. Like, I mean, you mentioned too, it's really important to bring in experts from other fields, and there definitely is a lot of research already done in a lot of the humanities spaces. So,
yeah, great question. So, at least our goal here was purely descriptive. I'm not an expert in any of the prescriptions or any of the very complex issues that you talked about. And so I don't feel comfortable being prescriptive at all in what to do about like bias in a particular application. And I think sort of the unsatisfactory answer is the right thing to do is going to depend on like this very specific context. Like sort of on this data set, in this specific application, today, what is the right thing to do? And there are definitely general rules that other people that are far more experts than I am have come up with. But no, the purpose of this paper was purely as descriptive of you can use these embeddings to say something about historical beliefs.
I was just asked if there are any kind of particular future directions that you either want to continue with this work or that you'd like to see other people take this work in.
Yeah, great questions. I think there definitely has been a lot of work in this line, very exciting work in this line. And so I think a few directions that I want to highlight is, one is, so on the technical side, there's a bunch of decisions that we made just for simplicity and to sort of reduce our degrees of freedom. So like one includes correcting for these frequencies. Another includes sort of exactly the algorithm that we use, that there's work on, instead of black box embeddings, can you use embeddings where the dimensions have a little more interpretation? Or embeddings that are smoother over time. So instead of just training differently on different data sets, can you sort of actually track the trajectory of a word as you add more data that's more and more recent? So I think on a technical angle, there's all sorts of improvements you can make to reduce the noise in the measurements. On sort of the application setting as well, is that we sort of sprayed on a bunch of I don't want to say random, but arbitrary applications, using somewhat ad hoc ways of constructing, for example, word lists and so on. I'm, in my opinion, principled in trying to find the most general list online, but I'm not an expert in any of the domains that sort of we apply the methodology to. So on an applied sense, I would love to have more domain experts, formalize, these are specific things we would want to look at. So for example, on the Asian stereotypes over time, I think there's a lot of work to be done on how narratives rise and fall and how competing narratives may play out in language. And I think that's something for an expert in that domain to explore.
I know you mentioned in the last answer to my previous question that part of the answer to can you improve the process or the calculation is, well, it's already pretty good. So given that, but from your last answer, it also sounds like you're also open to continuing to improve it further. I guess I have a question about the use of word embeddings in social sciences and these kind of things more generally. It's a super convenient and, as we see, fairly effective tool. But we also know that these kinds of word embeddings are a bit of a blunt instrument. They're linear models of co-occurrence matrices. They don't really capture the nuance of language. Do you or anybody else have looked at whether it's possible to do similar kinds of social science analyses using the richer representations in a kind of full nonlinear language model type representation? And would that be even useful?
Definitely useful. I have seen some recent work. I'm going to mess up the citation, so I'll send it to you offline instead of saying it over video. But yes, definitely. Yeah, so I think my two-part answer to this is, yes, they're pretty good in that I don't think we're missing like a 0th order thing that completely invalidates the methodology. But there's a lot of improvements to make it precise, to validate on different data sets, to use better approaches.
Then I could just, I guess, make a kind of shout out to a few papers, several of which you already mentioned, related to this question of where to debias embeddings, and I was glad you raised that question. So kind of the two papers from 2016, the Bollock-Bossi one was proposing a method to debias embeddings that used SVD as part of it. I always like to see shout outs to SVD. And then the Kaliskin, Bryson, and Naranjan paper said that they thought that the debiasing should occur at the point of action. And so typically, word embeddings are this kind of more basic building block in an application. And so the idea was like, if you debias then, bias can still seep into your application elsewhere. And perhaps even also, I think what Jeremy was getting at with kind of having complex interactions, and so you should debias at the point of action. And there was a paper earlier this year from Hilla Gonen and Yoav Goldberg. I don't know if you read this one, Lipstick on a Pig. Debiasing kind of covers up the structural biases but doesn't remove them. And so that was kind of more evidence for the point of debiasing at the point of action and not with the embeddings. So I just wanted to share those kind of perspectives. I don't know that there's a consensus, though, on how this should be dealt with.
Yeah. No, I think these are all great. And the consensus, or maybe there never will be a consensus. I'm sort of, my view, again, this is a very unexpert view, and that I haven't looked closely at any of these methods beyond just like cursory implementing a few of them, is that I think it's nice and good if you can debias at another stage, for example, at the point of action. But unfortunately, a lot of these language models are very end-to-end, and there might not be a convenient place where you can say this is where the action is. And so, yeah, whether the point of fixing some of these issues are at your model of the language or at some other downstream at, at the encoder, sort of at the decoder instead of the encoder, then yeah, I think that's still an open question. But yeah, that's my very small take.
Well, thank you. Any final questions? All right, well, thank you so much. We were so glad to have you.